A Portland Community College Mathematics Telecourse. A course in Arithmetic Review. Produced at Portland Community College. Being able to convert units, of course, has always been the very bread and butter of science and engineering. What most people don't realize is that it's also currently the bread and butter of business. But at the port of the city where I live, the longshoremen themselves are always having to convert metric tons to dry tons, kiloliters to gallons, etc., as we import and export our goods, the very lifeblood of much of our community. And as long as we're communicating with companies and countries using different systems, if we wish to trade, we will have to translate, not only language, but in units of measure. As it turns out, to be able to convert units is a very simple task. And we'll conclude this portion of the tape by showing you how to convert 60 miles an hour, say, into feet per minute, which is the usual way that an American physicist would measure a speeding particle rather than this. Actually, in pure physics, we would measure it in centimeters per second or meters per second. But let's see what kind of technique we will use or be involved with to do this conversion. Now, first you have to be given a conversion chart or memorize the equivalency of various units. Then, in addition to this, you must remember a very few simple facts. Try to memorize these immediately. They're very simple. Fact number one, let's review our cancellation law on the multiplication of fractions. It says if you're multiplying fractions and top and bottoms are multiplication or single numbers, you may divide anything you wish into a top multiplier. So I'll divide this 25 by 5. Providing I can divide some bottom multiplier, a single bottom multiplier, by the same amount. So I can divide 15 by 5 or 35 by 5. It's my choice. So I'll divide the 15 by 5. That process is where the word cancellation comes from. So remember, cancellation is really a division. Now notice I could divide this 5 by 5 once again. It goes in 1. But then I have to divide a bottom multiplier by 5, and I can see that I can do it with 35. So there's one more cancellation. And now I see I can divide this 7 and this 14 by 7. Goes in once here, twice here. This one you might not see so readily. 13 goes into both 26 and 39. Goes into 26 twice, 39 3 times. Now, there is nothing that will divide into a top multiplier that will also divide into a bottom. So that means I can multiply the tops to get the new top, the bottoms to get the new bottom, and my result is reduced. So the cancellation law says, in effect, if I am multiplying, I may reduce before I multiply, and I can reduce or cancel anywhere as long as it's top for bottom. So know the cancellation law. That's going to be the key tool in this process. The next idea to keep in mind is to treat a measurement as though it were a multiplication. Instead of thinking 3 centimeters, begin to think 3 times centimeters. Certainly if I had 3 times a variable, which is some number, we would know that this implied proximity here means times. So that's 3 times some number called c. We wish us to treat the units of measurement the same way, as though they were times. Now if we treat this as times, and this of course is times, the conditions are legal for me to cancel. So now I can divide 2 into this 6, 2 into this 8, but now I can divide centimeter into centimeter once and centimeter into centimeter once, because anything divides into itself once, which brings us to our second principle, or third, which is simply the readily known fact that anything divided by itself is equal to 1. An obvious fact, but it's going to be important, and it's going to allow us to say 1 in some rather strange way. For instance, consider this. We know from our tables that 5,280 feet is the same measurement as 1 mile. Now watch this. I'm going to claim that this fraction indeed is equal to the number 1. It certainly doesn't look like it, does it? But notice, we know from this conversion equivalency that this measurement and this measurement are the same. And we know from this statement up here, anything divided by itself is 1. So I have a measurement divided by its equivalent, so it must be 1. And indeed it is. I could have also have written that 1 this way. That's why a couple of units ago we made such a big issue out of the fact of not considering this as 5,280 with the word stuck behind it. It is a number, and that number is equivalent to that measurement number even though they are equal. And the same thing is here. So as long as the top is equivalent to the bottom, you indeed have a fancy form of 1. And our fourth fact to bear in mind is the obvious statement that any number times 1 is still the same number, or multiplication by 1 does not change what the number really is. Now let's bear those 4 facts strongly in mind. First, the cancellation law. Then that we will consider a unit of measure as a sort of multiplication, which will allow us to cancel units as well as into number multipliers. Third, any quantity divided by its equivalent is equal to 1. And finally, 1 times any number will not change what it is, even though it might look different. Those 4 facts, and only those 4, are the tools for conversion of units. Let's say for some reason you needed to know how many centimeters is equivalent to 48 inches. Now the first part of our task is to find in a conversion table some relationship, some equivalent relationship between inches and centimeters. Looking that up, we might find this. There are several others that would also work. Then we simply start with what we have, and I'll write that as a fraction. 48 times inches over 1. That's a fraction. Now, I think this way. If I were multiplying by another fraction, and because of the cancellation law, if I had an inch on the bottom, I could cancel that inch off. So I concentrate first not on what I want, but what I want to get rid of. So in my conversion equivalency, I notice that 1 inch is equivalent to 2.54 centimeters. So if I write one on top of the other, I really have a form of 1. And if I'm multiplying by 1, I don't change anything. But now, because I'm multiplying, I can cancel the inches off, and what I have left is centimeters, and it says that I have 48 times 2.54 centimeters. So it's not only telling me that I have centimeters, it's telling me what to do with those numerical coefficients or multipliers. And multiplying, and I have my answer. The 48 inches is 121.9 centimeters. Really, that's the whole show right there. So let's back up and see what we did. First, we concentrated what we wanted to get rid of. We tried to find an equivalency in a chart that gave me what I wanted to get rid of and a relationship with what I wanted. Okay, I put the side of the equation with the thing I want to get rid of on the opposite side of the fraction sign so it'll cancel. I put the other side of the equivalency on the other side, top in this case, so that I would know that this is equal to this. And that's a very important point. I cannot do any of this if ever the top is not equal to the bottom. Then I cancel what I want to get rid of, and that brings in what I want. So again, you concentrate on what you want to get rid of and equivalencies. Then in effect, you're really multiplying by 1. Let's try that same approach now with a longer problem. Then after that, we're going to come back to the same problem and do it from a slightly different approach. Now let's do this one. Really, this is not a longer problem, it's two problems. We're going to want to convert miles, which is length, to feet, which is length, and then hours, which is time, to minutes, which is time. But remember our strategy? We're going to concentrate one by one upon the unit of measure which you wish to get rid of. And think, I want the situation set up to be such that that thing will cancel out. Bear that in mind and everything stays clear and smooth. Let's concentrate on miles first and leave hours alone. This strategy says I want something with miles on the bottom. Hopefully that also has feet, so that I can go from miles to feet in one move. But it's miles that I concentrate on. So checking my equivalency chart, I see that 5,280 feet is 1 mile. So the side that has what I want to get rid of, I will put on the bottom, so that being on the bottom, it will cancel the thing I want. So there it is. The 1 mile is on the bottom. And I can see that what I wanted to get rid of is going to go. But now I need an equal amount, always an equal amount on top. So I'll put the 5,280 feet on top. So I did cancel out my miles, and I did end up with feet, and that's part of what I wanted. I wanted feet, I have feet. So now we'll concentrate on trying to convert the hours to minutes. But remember, you concentrate on what you know about what you want to get rid of. So we ask, what do we know about hours? Well, without even looking it up, we know that 1 hour is 60 minutes. But notice the thing I wanted to get rid of, hours, is on the bottom. So I must put something with hours on top, and then something that's equal to it on the bottom. Now, the top is equal to the bottom. If the top is not equal to the bottom, I'm on the wrong track. But now notice the hour on top cancels the hour on the bottom, and I'm left with minutes. So I have a unit of measure which is measured in feet per minute. Feet per minute, and that's exactly what I want. Now, as far as the arithmetic is concerned, all I have to do, I simply tend to any remaining cancellation. So simply reading what I have left, I have 5,280 feet times feet over 1 minute. So I have that 60 miles per hour is the same thing as 5,280 feet per minute. Now let's say our problem suddenly changed on us. What if someone changes their mind and says, I don't want to know how many feet per minute it is, I want to know how many feet per second that is? Well, we can simply move one more step. Now we're simply saying I want to get rid of minutes and hopefully pull in seconds. And then we recall that 60 seconds is 1 minute, so we think it's a minute I want to get rid of. It's on the bottom. I need a minute on top. Therefore, I'll put this minute side of the equivalency on top and an equal equivalency on the bottom. Now, minute cancels with minute, and I'm left with feet per second. 60 goes into here, 1 goes into here, 80, 8, so I have 88 times feet on top and 1 times second on the bottom. So we have that 60 miles an hour is the same rate as 88 feet per second. Remember our key idea? Concentrate one by one upon the unit of measure which you wish to get rid of, and think, I want the situation to be such that it will cancel out. So in this case, I wanted minute on top to cancel minute on the bottom. But always remember, the situation that makes that work is the top must be equivalent to the bottom, which we get from tables. Now let's attack a simpler problem by yet another method. Let's go back to our first problem and recall our work with proportions. Recall that we have a situation here. We'll call that situation 1. We have 48 inches is equivalent to an unknown amount of centimeters. The table, in effect, gives us a second situation against which we can compare it. So remember, we can write this in any order we want, inch to centimeter or centimeter inches, as long as the other situation is written in the same order. So I want inches here. So from the table, I have 1 inch. I want centimeters here, and from our table, that 1 inch is 2.54 centimeters. Now we have inch, inch, centimeter, centimeter. One of them is unknown. Here's our proportion. Top times bottom equals bottom times top. And we get this. And doing our multiplication, we get the same answer we had before, 121.9 centimeters. Now, when you have a problem which you can go from one to the other directly, the proportion sometimes is a bit faster. However, when you have many steps to take, this multiplication property of 1 is the technique we wish to use, and we one by one keep getting rid of what we don't want until we end up with what we do want. Let's now show that we can combine this lesson with the last lesson. In this case, hopefully you recognize that I'm going from a metric unit, hectogram, into another metric unit, decigrams. We recognize that the last letter tells me what kind of unit I'm in, gram, that's a weight unit. This is telling me how many of them I want into another way of measuring that same weight unit. So rather than using the technique we did on the last lesson, which is a very good one, we could use the technique of this lesson. We recognize that hecto, 1 hectogram, but hecto means 100. So hectogram means 100 grams. So last time we simply replaced the H by 100 and we get the 100 grams. But we also want to get into decigrams. And this says that 1 decigram, but deci means a tenth, so that means 1/10 of a gram. Now, using the technique of this particular lesson, we start with the units we want to move out of, write it as a fraction if it isn't already. We're going to multiply. What we multiply by must be logically equivalent to 1 or I can't do it. We concentrate on what I want to get rid of, which is Hg. So we find anything with an Hg and put it on the bottom, because we can only cancel top with bottom, or bottom with top. So here is an Hg, one of them, could have been anything. but now we must put an equal amount on top. And we ask only one question at the start: did I get rid of what I wanted to get rid of? In this case, hectogram. The answer is yes. Is the top actually equal to the bottom? The answer is yes. Then that tells me I'm on the right track. Then I ask, did I get what I wanted? I got grams, but I wanted decigrams. If I don't have what I want, then that doesn't mean that I'm working wrongly. It simply means I'm not done. I have additional steps. So now I concentrate on getting rid of grams. So I find anything with gram in it, G, to put on the bottom to cancel that G on top. Hopefully I find something that also has what I want. So in this case, here's a gram and here's a dg or decigram. So I put this amount on the bottom. Why? Because it gets rid of this one I want to get rid of. And then I put an equivalent amount on top to guarantee that this whole multiplier is still logically equal to 1. Now again, the top was equal to the bottom, so I am multiplying by 1. I did get rid of what I wanted to get rid of. That tells me I'm on the right track. And the fact that I ended with what I wanted to end with tells me that, in fact, I'm done. An important fact: do you recognize that it's attention to the units that's telling me what to do and how to do it, and not the numbers? The number part is that which we take care of sort of after the fact, after our units have already directed my traffic flow for working the problems. So this matter of units, as it turns out, is the most important part of the measurement number. And many of us in our earlier schooling would sort of work with the numbers and just stick this on when we were all done to sort of please the textbook answer or the teacher. And as it turns out, these units are the most important part of the work. Now, after the fact that we know we have worked properly, we know that we've gotten rid of what we wanted to get rid of, we know that we end with what we want, then and only then do we backtrack and take care of the arithmetic. In this case, since we're multiplying by powers of tens and dividing by powers of tens, we utilize what we learned in our chapter on decimals and simply move the decimal point. Multiplying by a power of 10 says to make bigger by 2 places. And here we can either divide by 0.01, or I can think this way. If I were to multiply this by 10, it would become 1. But then I would have to multiply the top by 10, which now says to make bigger by 1 more place, which is here. So we end with 5 decigrams. So 52 ten-thousandths of a hectogram is 5 decigram. Let's do one of these, because once you see the pattern, it's a remarkably simple process. Do you recognize this as being metric and this as being English? Frequently, the English abbreviations will end with a period. A metric system never will. In the metric system, it's the last single letter that tells me what kind of unit I have. In this case, a meter. And the prefix dA tells me how large or how small of units of meter I want. We recall, hopefully from memorization now, that dA is 10 meters. So let's make a note of that. 1 dA is 10 m's. And if we wish to go into inches, we notice that another table says a 2.54 cm, centimeter, is 1 inch. So this will let me go from dA to m But I don't want m, I want inches. Well, this will let me go from cm to inch, but I need somehow to get from meter to centimeter. Well, here we again had memorized that c means 100th, so 1 centimeter is also 100th of a meter. So we get a plan of operations here. We can go from dA to m, we can go from m to cm, and now we can go from cm to inch, and we're done. But we don't really have to fret that much about it, because by using the strategy we had just set up, we had noted that we're always multiplying by 1, and we always concentrate on what I want to get rid of. So I want to get rid of this, so I need some of this on the bottom. This will do it for me. I have a, should be DAM, shouldn't it? I have 1 DAM decameter is equal to 10 meters. I did get rid of what I wanted to get rid of, but I didn't end with what I wanted. So now I concentrate on getting rid of m. So here is an m. I put it now on the bottom so that its m will cancel the m on top. But then I must put an equal amount on top to guarantee that I am multiplying by 1, something over its equivalent. But I still didn't end with what I wanted to end, so now I concentrate on getting rid of this. And I also note that I want it on the bottom, so that it'll cancel that. So here is something with centimeters. I'll put it on the bottom, and an equal amount on top. Now I did get rid of what I wanted to get rid of, and now in this case I ended with a unit I wanted to. So since all of these are logically equal to 1, I'm multiplying by 1, which tells me nothing has changed, so all that remains for me is to do the arithmetic after the fact. So I want to multiply this by 10, divide by 100th, then divide again by 2.54, and that will convert this to inches. And we can do the multiplications and divisions, if we wish, on a calculator. In doing so, I got an unending decimal, which told me I needed to round off at some designated point. Once you see the strategy, you can realize I can translate from anything I wish to anything else I wish by repeated multiplications of 1 and by facts which I get out of conversion tables. It's really just that simple. This is your math host, Bob Fennell. Good luck.